Hello, everyone. Morning, afternoon, evening, depending on where you are. We'll get started in a couple of minutes, but just want to start with the introduction. My name is Abhinav Modi, and I'm a product manager with the Avi Load Balancer team here at Broadcom. With me, we have Chris. Chris, why don't you introduce yourself?
Yeah, hi everyone. My name is Chris Grice. I'm also a product manager with the Avi team. Good to be here today.
Cool. So today's topic for the webinar is what's new in Avi Load Balancer, ADC and Container Ingress innovations. So we'll be covering the features and the goodness which we just launched in January in our latest releases, along with an overview of what's happening in the ADC market. So please do put your questions in the Q&A panel, and one of us will get to it. Let's get started. The agenda is we'll just give a brief overview of Avi Load Balancer for those of you who may be new to it. We'll look at what we did in the last year, as well as what the key features are in the recent feature release 31.1.1, which is the first release of this calendar year. We'll also look at the container ingress landscape and what we've been doing on that front. We have a couple of releases timed with the Avi 31.1.1 release. So before we get into the feature set, just wanted to present a bit of what we're seeing in terms of the market shifts and the trends which are driving both Avi and the ADC strategies in general. So one, we see a move towards infrastructure as a service cloud. So private cloud is something which is coming back in the forefront. We see a lot of interest in a lot of focus on security. So application risk security, as well as the amount of ransomware which is happening, means that there is a bunch of work which can be done on the application delivery controller, the load balancer. The application economy is here to stay. So, most of the traffic on the internet is now powered by APIs and, applications which are running on APIs. And then we all know about artificial intelligence as well as Gen AI assistance. So most products, most companies are looking at what we can do to leverage these technologies, to get better efficiency, to get better features, better troubleshooting. So overall, the guiding principles for us as we look into the coming year, as well as what we did, was first look at from an IaaS cloud perspective, how do we get better aligned towards a cloud operating model on the private cloud, which is software-defined self-service scale-out. And we'll see how Avi has been built, from the get-go with that in mind. On the security side, we look at how application security, is enabled by Avi and its WAF features. On the application side, as we mentioned, the application economy is here to stay, which also means that your applications have to be resilient and performant. So both in terms of the overall speeds and feeds which are required, as well as in terms of the troubleshooting and availability of applications. The health score and analytics become a key driver and important point. And finally, we look at what we're doing for co-pilots, in terms of security and load balancing to help augment the troubleshooting and analytics which we have. So overall, as you know, Avi and VMware, which is part by Broadcom, has been focusing on VCF, which is the VMware Cloud Foundation, which provides a private cloud platform. And on that, we will see how Avi is innovating and developing our feature set to be the next gen load balancer for a secure and application resilient VCF stack. So before we get into the feature set, let's have a quick overview of what the Avi Load Balancer tenets have been. The reason for Avi to be founded was that before Avi, the load balancing and application delivery was a legacy mode. So the challenges were control plane, management plane, and data plane was all monolithic. So operational complexity in terms of configuring and managing each load balancer box by box, especially if you're a large company, you have tens or hundreds of load balancers with thousands of virtual services or applications to load balance. Both scale as well as configuration and operational were a bit of a challenge. In addition, a load balancer is right in the middle of the traffic. It is doing typically SSL offload or SSL re-encryption with traffic coming in from the client and then going to the backend servers. So it is a very good vantage point in terms of the analytics and visibility it can provide. However, what we saw was that there was a gap in the market in terms of the analytics which the legacy load balancers provided. And those are the things which Avi, started to tackle and, to get better at when it was founded. So overall, at a very high level, Avi is a distributed software-defined, software-only platform. It has a management and control plane, which runs on premises within, your network. And what it does is it provides you with a way to deploy automatically load balancing instances called service engines, which is the lower half of this stream, the data plane. The benefits of this is that the control plane, the controller, the Avi controller as we call it, is a single point for control, for visibility, for deployment. And the controller is the brains behind the whole operation, because it provides you with a fabric. It automatically deploys the load balancing instances, which we call the service engines. It manages its life cycle, and it talks to the various environments, whether it is vSphere, whether it is VCF, whether it is NSX or public cloud, to be able to spin up and deploy those load balancers and deploy applications in that. In addition, it also provides us with a application visibility and a very great dashboard. So that's what Avi is. It is still the forefront in terms of being the first and only private cloud automated load balancer with a control plane, a very distributed and resilient control plane, as well as scale-out architecture for the plane. In addition, it provides load balancing, global load balancing or GSLB, as well as application security, including WAF, bot detection and management and DDoS. We'll take a look at a demo very quickly later on. But overall, what we've seen with our customers is a 20x reduction in the appliances, because you just have to manage that controller, and that does the work of deployment and management of the load balancers. And so your operational simplification is massive in terms of what you can achieve. So overall, to sum up, Avi, these are the numbers which we've seen. Some of these have been backed by independent research. Avi provides all of these capabilities: local server load balancing, GSLB, container ingress, which is an important item which Chris will cover as workloads become more containerized, web application firewall, and then the other things. And this is not just for small deployments. We have deployments where we have 40,000 plus virtual machines and 17,000 virtual services or applications running for a single customer. One customer has 9,000 plus GSLB services, and another one has a large financial has 2,500 WAF services or WAF on Avi and join. And then it is completely multi-tenant, so we have 1,000 plus tenants deployed for a customer. We'll look at this in the demo, but overall, one of the key items is the application visibility, and this is something which we are working on enhancing as well. We have done a bunch of stuff in 31.1.1 as well. So with that, what Avi can do is provide you with end-to-end latency analytics, can provide you with logging, can help troubleshoot any application or network issues which it sees when it's doing the proxy. So let's take a look at the features and the key themes which we worked on in the last calendar year before we get into the next year. And if you have any questions, do type it into the QA panel, and Chris or one of the panelists will get to it. So one of the key items which I've been working on and continue to work on is integration with VCF. VCF, or the VMware Cloud Foundation, is the private cloud stack for VMware and Broadcom. It provides you with a full stack multi-tenant, which provides both virtualized as well as container application, as well as application hosting. Okay? So over there, Avi has always been able to deploy in VCF, but over the last release, we started integrating better with the SDDC or this SDDC manager in VCF to be able to do lifecycle management of the Avi controller as along with the VCF by VCF SDDC manager. In addition, from an automation perspective, we started supporting VRA or vRealize automation, now called VCF automation with the Avi plugin. And that's something which we made generally available last year, and we continue to deploy that. In addition, we have had a bunch of features around IPv6 management and data plane. We always supported data plane, but there were a few additional features we want to support. And in addition, we have IPv6 management plane support as well now. On the container ingress, we have made key investments into gateway API as customers and the community's world. Container ingress moves towards gateway API for application specifications. We support dual stack as well as added support for other CNIs like Cilium and OV and OpenShift. On app security, a bunch of features around CSRF protection and Avi WAF, certificate management, and authentication. One of the key pain points for customers has been migration from their legacy LBs to Avi. So we launched a tool called Avi Converter Tool, ACT. It is generally available for customers, and that can provide you with a bunch of migration possibilities from your existing legacy load balancer like an F5 or even an SXLB into Avi. And finally, as customers deploy us in more and more demanding and high-scale environments, we continue pushing the boundaries on the scales, as well as resilience. So, tier 1 scales in terms of the number of virtual services on a single controller, those have been increased. In addition, we have also worked on getting upgrade more resilient by providing a pre-check and try run. So coming to Avi 31.1.1, this was the first release, as I mentioned, of this year. January 31st was the day. And we also followed that up closely with the container ingress features and product AKO or Avi Kubernetes Operator and AMKO, Avi Multi-Kubernetes Operator. So we continued on the themes which we worked on last year for 31.1.1 as well. The key points, and we'll get into this more detail, was more VCF integration, support for multi-AZ deployments, a bunch of core load balancing features in terms of again the IPv6 as well as SCTP or for telco. On the container ingress side, Chris will talk about additional gateway API features as well as some of the enhancements on getting HTTP policy supported in a native manner. On the app security, we started supporting IPv6 reputation. We already supported IP reputation for IPv4. In addition, a bunch of enhancements for WAF in terms of getting the analytic visibility into how much processing power is required per role, and some of the regular expression. On the user interface and experience, we have been working over the past couple of years on getting the UI modernized into the Clarity UI. So you'll see a new virtual service topology page, which provides you with a good dashboard of how your virtual service is looking like, all the key objects which constitute a virtual service, for example, the pools, the policies, the profiles, which are applied. We have an improved virtual security VS security dashboard, which provides you with a widget form of items which we already present, and that helps us in getting more features in. We have a new GSLB topology view, as well as a new Avi logs and analytics. And finally, on the scale and performance side, we start supporting Intel QAT for SSL offload to better performance on the data path. We support GVNIC in Google Cloud Platform, again, for more performance, throughput performance. And then we added scale in terms of the number of tenants we support on an NSX cloud environment, as well as DNS environments. So let's get into some of the features and in a bit more detail. Let's look at what we're doing with the VCF environment. So typical challenges for a VCF, a VCF provides you with a full stack of a management domain, which provides you with the way to control your VCF environment, and then workload domains, which can be hosting your end applications. Typically, a customer would have multiple workload domains in the environment. So the challenge with legacy load balancers or a hardware load balancer, a virtualized monolith load balancer is also in some sense the same. One, you may have to hairpin traffic external to VCF, especially if it's a hardware load balancer, before it comes back in. In terms of self-service, there is a lack of that because these are not API-first devices. And then you need an infra owner as well as to actually first deploy the load balancers and then the developer to provision of it. Right? So it takes sometimes weeks, if not months, to deploy a load balancing pair, then upgrade, or to get a application front-ended by a load balancer. If you're looking for auto scaling, that is not possible because the load balancers are typically static capacity. If you want more capacity, you need to plumb that into first procure it and then plumb it in. And then there are multiple management points because each load balancing instance is a separate load balancing a control point. So with VCF, what we have is a very unified stack, which is more DevOps friendly. We have the VCF management domain, which hosts the SDDC manager, the ARIA automation, and then you also have the Avi controller and the Kubernetes clusters potentially running there. All of this driven by VRA or with your own automation, like Ansible or Terraform. The workload domains can host these service engines. So the controller can be a single point or be flexible to be multiple controllers. And then the service engines are deployed by the controller as needed. So with that, what we can do, and in 2111, we also had SDDC manager integration for the lifecycle of the Avi controller. So the Avi controller can be deployed automatically by the SDDC manager, and then it deploys the service engines automatically, connecting to the VCF and to the vSphere and NSX in each of the workload domains. So why is this important? First, as workload domains become more dense and have more demand, performance becomes a important item. And if your hosts are getting in, support QAT, then the performance of the LB also gets automatically enhanced with 3111 if you're running in a QAT environment. We have increased the virtual service scale, and so we have a new form factor for the controller, which is extra large, which can help with a large scale deployment of the controller if you have multiple thousands of virtual services available. Application availability zone awareness has been an important ask for vCenter NSX deployments. And with 3111, we started supporting multi-AZ. So that ensures that when your application can now span easy boundaries and provide better resilience. And finally, Container Ingress, as we mentioned, gaining traction. We'll see how that, if your container applications are hosted within VCF, those can benefit from these features as well. So let's look at, what would be the QAT. QAT or Intel Quick Assist technology is an SSL offload technology. With Avi for QAT, what we have is the capability has been there for a while, but starting 3111, Avi service engines can utilize those functions to offload the SSL. So with that, with 3111, we see up to 6x of SSL transaction TPS performance improvements. And then the cost performance, for these workloads becomes much better. So with that, as you can see, a single vCPU RSA2K, if it was 950 SSL transactions per second, there's around 6,000 plus, with hardware QAT and Gen 4 supported software hardware or hosts. And we'll build upon that in the next releases. Coming to the features around the performance and scale. First of all, what we had was, as I mentioned, SSL transaction, SSL TPS performance has been increased. The number of WAF tenants has also increased from 800 in 30.x to 1500 and 31. We have improved WAF virtual service scale. So, an exarch controller can support 4,000 virtual services versus 2,500 earlier. And then VS virtual service scale per controller has also increased from 10,000 to 50,000. Right. So with that, the number of controllers required to manage your application estate becomes lower. And then the controllers and the service engines are more performant for better resource utilization. So let's look at how we do this in terms of the VCF workloads and in terms of the multi-tenancy. So as you can see, we earlier supported 300 tenants per Avi controller. That number went to 800 words in 30.2.x. And in 31.1.1, we have 1,500 tenants per Avi controller. So with that, if you're running in NSX and VCF workloads, you can go to a maximum of 1,500 tenants or 1,500 tier ones with a single Avi controller. Any questions up here, Chris?
No, not yet.
Okay, cool. So let's look at some of the multi-AZ and the application AZ awareness features which we provided in 31.1.1. So one of the items which Avi has been very successful in is that when we deploy the controller, the controller talks to the service, to the vCenter, and it understands the topology over there. So what clusters are there, what hosts are there, all of that is available to the Avi controller. Starting with 31.1.1, what we can do is we can also assign, have more granular control about what clusters are provided in a particular AZ. So with that, the service engine placement to, let's say, a particular cluster and to a particular AZ becomes more easy to do. So with that, for example, with an AZ aware deployment in 31.1.1, you could have the service engine span the clusters and thus the AZs. While earlier there could be a chance that everything would be in a single cluster. Similarly, in case of the same thing earlier was for VCF in the previous slide, for vCenter in the previous slide. In case of NSX cloud as well, what we can do is it can span across multiple vCenters if if the NSX has multiple vCenters, and you can assign vCenter 1 and vCenter 2 and deploy services across those two. So as you can see over here, the AZ1 has the first service engine, and then the second service engine and the third service engine go into AZ2 and AZ3, which is a different vCenter, again with the same NSX cloud. So let's take a quick look at the user interface, and then we'll go to a quick demo. These are a few screenshots, but we'll look at it live. I just kept this for reference. The first is the admin view, which provides you with the controller and system health in terms of what the overall controller health, the CPU utilization, all of that is, what licensing looks like. So it's more of an administrative view. We have a revamped VS topology view, as I mentioned, the security dashboard, and then the application log view, which is one of the key items which we have. So let's look at it live in a demo, and then we'll go to the additional topics. So I'm going to log in into the controller. This controller is running in my in my data center. So it's available in the in a vCenter environment. And when I log in, I get a fully tenant view. I'm in the admin tenant right now. So the day one or day zero operation is to connect this controller to the vCenter, where it will be deploying the load balance, the service engines, or the load balancers. So for that, I would just go into the infrastructure view, go to a cloud, and create a cloud connector. So this is the cloud. This would have been blank, but I would just create a cloud of type vCenter over here. I could use an NSX cloud as well. And when I do that and provide it with the vCenter credentials, the Avi controller will make a connection to the vCenter. It will start understanding the topology and the objects. For example, over here, we see all the content libraries it has discovered. It will discover all the port groups. If it is an NSX cloud, it will also look at the the tier ones and the subnets. And with this configuration, the cloud will be ready for deployment of a service engine when required. Let's go into the demo tenant, which is again a separate tenant. And this is where we deploy the application. So as you can see, I have a bunch of applications over here. And again, from an analytics perspective, this provides you with a good view of the health. We have a color coding. Green is great. Yellow is, there are some challenges, and orange is a bit more. Red is reserved for a VS, which is down, or application which is down. So let's get into a click through a particular application, and let's go through each of the views. So the topology view provides us with a sort of a snapshot of what is this application looks like. Example over here, we look at the VS Web, the number of policies, which policies are available, and then you can click through to that policy. The middle column is the pools, so which pools, and then the pool members, and on the rightmost is the servers or the backend pool members in that particular pool. So in this case, the application has 3 pools. The first pool has 3 members. We also see the health, with the health monitors. For example, over here, all things look good. This pool member looks red, and if you hover, we can see that they've been marked down by the system HTTP. Below this, we also get into the information about the service engines, which are hosting this application. In this case, we see that there are 3 service engines. So this application is scaled out active onto 3 service engines. Let's get to the analytics view. So this is an overall view of how the application is doing. It has views around 6 hours, a day, a week, all of that. This is due for a refresh, and we will refresh it in the next release. But overall, this provides you with a very good view of things like end-to-end timing, for example. And over here, we can see that we have trending analysis to say that the application end-to-end time or the latency increased, for a brief period. Let's go to the log view, which has been revamped, and we can drill down into what exactly happened. So the log view is a filtered filtered view of each request which comes in. So we throttle it for performance, but each of these entries which you see below is actually a single request coming from the client, and then load service by the load balancer. And for each of these requests, as you can see, we have a bunch of application analytics data points which are available on the client side, where it is coming from, what the user agent or the browser is, which server or the pool member actually serviced this request, what the response was, how much time it took, and then what the policy actions were. So with this, you could drill down into each of these in a more general fashion to see if things are wrong. For example, if I wanted to look at a 404 error coming in, I could just go to the response code and just drill down on the 404, and then figure out what type of traffic is is causing a 404. In this case, we see most of it is coming in from for a particular asset, which is logo.png, right? And on a particular server, which is this server. So with this, the amount of troubleshooting which you have to do from a load balancing perspective becomes, between the network or the application, becomes very easy. We call it mean time to innocence, because it is able to pinpoint the issue in a matter of minutes, and doesn't take too much back and forth. And this being fully multi-tenant and RBAC controlled, you can provide this view read-only to your application owners as well. So this is what I had in terms of the features on 31.1.1 on the core. The software is available for customers for download. You can do a trial license as well. You just log into the Broadcom support portal and then go through it. Then you can do the 90-day trial for this, to deploy and to try this out. For the next part, Chris, do you want to take over and talk about?
Yeah, absolutely. Thank you very much, Abhinav. 1 second.
Any questions?
No questions in the chat.
Cool.
Maybe one just popped in.
Yeah, I'll cover it.
Yes. Without further ado, so first of all, what I want to talk about is the ACT tool, which the latest version is 2.7.1 and is now GA. First of all, let's talk about what the AC tool is and what does it do. The reason we have the ACT tool is fundamentally, we have many customers that have existing load balancers. And one of the things that they struggle with when they're migrating from an existing load balancer to perhaps Avi is that there's a lot of sort of custom configs, custom rules that exist on the older load balancer. So from an F5 perspective, this could be an I rule, and depending on what sort of load balancer is, there could be various different things that can make it a little bit complex to migrate. So the idea of the tool is to sort of make that simple. So what we can do is we can ingest configuration into the tool, and then we can output a configuration that you can easily apply to the Avi controller via things like Ansible playbooks, etc., etc. And we've had some good success with the tool. As you can kind of see here, it's not absolutely infallible. It doesn't. It's not going to take the most complex configuration from an F5 in the world and sort of output it immediately. But you can see here that 45% of sort of existing I rules we can convert, and that leads to a sort of 60% faster conversion rate from a sort of existing load balancer to an Avi controller. So at the end of the day, the tool is sort of making everybody's life easier and helping you move from one load balancer to the other. So that's generally an overview of what the tool does and how it's come into existence. So what's happened in the last version? So the last version, was 2.7.1. And I will say that the releases on the ACT tool, they come out very rapidly. So one of the things I will say is if you are using this tool or you're looking to use the tool and you need some assistance, please let us know. We can engage and we can also bring in new features as well. But a couple of key highlights, I won't go through this all, but simplified deployment, static IP is now supported. We've got some new specific F5 to Avi features, certificates. We've improved that conversion ratio. And then we've also added support for NSX load balancer to Avi workflows as well. So this is helping you with traffic cutover, cleaning up any configuration. And then sort of alluding to the previous point on, us wanting feedback from customers using the tool, we've actually enabled embedded feedback into the tool as well. So you can give your feedback via the tool and, we can understand that and we can generally just make the tool better. And that's really what our goal is there. So yeah, that's just a quick discussion on the ACT tool. We'll move over to Container Ingress. Just checking if there was any questions on the ACT tool, Abhinav? I'm not sure. Perhaps not.
No, I can go ahead.
Okay, perfect. Yeah, so sort of sidelining into Container Ingress, and here we'll sort of focus on AKO and AMKO. Very first, what I'll do is I'll just quickly explain what these are and how they kind of relate to Kubernetes and the Avi controller. But fundamentally, the Avi Kubernetes operator is an operator that runs inside Kubernetes. It provides sort of ingress, provides load balancing functionality. And why did it come about? Well, we noticed that there were some common kind of concerns and designs within sort of the existing Kubernetes ecosystem, and you can kind of sort of see that on the left-hand side there, where I have a Kubernetes cluster at the bottom. Then I might have an ingress controller in front of it, routing layer 7 traffic. Of course, in front of that, I need a layer 4 load balancer. If I want to do multi-cluster, I might need GSLB, I might need a WAF, I might need DNS, I might need IPAM, etc., etc. And these are all the pieces you really need to sort of get your Kubernetes, applications, your pieces of the business that are running inside Kubernetes. You need all of these pieces to get your applications to market. And although you can use all of these, you can see some of the problems there at the bottom there. There's a lot of complexity with managing all these different products, difficult to automate. And also, how do I get visibility? Visibility helps me troubleshoot what's happening in the environment. It helps me from a capacity perspective. And piecing together all of these different pieces from all of these different tool sets can be difficult. So that's really where we come in. As you can see on the right-hand side there, we kind of provide ingress, load balancer, WAF, GSLB, DNS, IPAM, and we provide it from a single solution. And in this slide in particular, we're focusing on VCF and VKS. But we're pretty agnostic to whatever Kubernetes solution you may have. That includes OpenShift, includes public cloud, etc., etc. We kind of bring all of those pieces into a single tool, and we can really help operate and manage and give you that visibility that you need to manage your Kubernetes clusters holistically, and sort of help with those capacity issues, help with that troubleshooting, help with that automation. So quickly, what makes up the product? So Abhinav, went into detail earlier about what the sort of Avi controller was and what the Avi data plane was, the service engine. So I'll skip past those. But from a Kubernetes perspective, what are the important pieces? And you can see here that we have our operator, the Avi Kubernetes operator. That's going to run in every single cluster that you have. So irregardless of OpenShift, Kubernetes, or TKG, VKS, you'll have an AMKO operator running inside that cluster. The operator's job is to fundamentally translate Kubernetes API objects into Avi controller objects. So think of ingress, think of service type load balancer, think of gateway APIs. AMKO has watchers into Kube API, so it knows when those APIs have been engaged, and it converts those Kubernetes APIs into Avi controller APIs, which then the controller configures those objects on the service engine. So that's kind of how that process happens. Developer pushes a object into Kubernetes, AMKO realizes that, tells the controller what to do, and then the controller tells the service engines what to do, and then the traffic flows through the service engine. On top of that, we also have a multi-cluster operator, an Avi multi-cluster operator, AMKO. What this is doing is, if you think of, Avi as a whole is an enterprise-grade load balancer. So it has enterprise-grade features. One of those features is GSLB. And what AMKO does is it kind of brings the power of GSLB to Kubernetes. So this enables you to take advantage of, geolocation algorithms, various different, GSLB algorithms, health checks, traffic weighting, priority. So I can have active, standby, active. It gives me a lot of flexibility in what I can do to expose my applications across a multi-cluster or multi-site environment. So it gives me a lot of flexibility to do that. From so that's kind of a high level on what AMKO and AMKO do. What do we focus on from the last release, and what are our sort of key tenements of the last release? A big piece of this, and we've mentioned it a few times through the presentation, is Gateway API. Gateway API is the kind of future of Kubernetes Ingress. If you sort of follow KubeCon and things of that nature, open source Ingress Nginx have announced that in the next 18 months they'll be deprecating sort of the Ingress feature, and they've come up with a new product, not new product, but new open source project called Ingate, which is basically taking Ingress and migrating it to Gateway API. So we're right there with them. Gateway API is sort of the future here, so we want to be right on that edge too. We've also spent some time sort of configuring, enabling you to sort of natively configure advanced traffic routing pieces natively via Kubernetes. Avi as a whole, if you look at this as a load balancing product, we have a lot of advanced layer 7 features. We can do a lot of advanced traffic routing, cookie-based routing, header manipulation, all of those things. One of the pieces we've done in this release is to make that natively, to be able to consume that natively from Kubernetes YAML versus having to come to the controller. And then on top of that, we've also offered sort of true multi-tenancy for both AKO and AMKO. And what this means is that a single AKO operator sat within a single cluster can manage multiple tenants. So each namespace within my Kubernetes cluster could have its own tenant, and that goes for the AMKO piece as well. So really giving you a lot of flexibility from a tenancy perspective, an advanced traffic routing perspective, and also looking into the future as enterprises and corporations start embracing Gateway API. Bit of a deep dive into sort of what the AKO AMKO release gave us. So this release sort of came out quite recently. From a version perspective, we support all of the Avi controller versions that are currently under support today. So you can see them all there. From a Kubernetes version perspective, we support 127 to 131. From an OpenShift perspective, 414 to 417. I will note as well that as Kubernetes releases pretty rapidly, sort of 3 to 4 times a year, same with OpenShift. We will add support for newer versions as they come as sort of maintenance releases. So look for like 113.2, 113.3. Those releases will include the later versions as they come around. From a feature perspective, quite a featured release. We support HTTP 2 from the front to the back end now. The HTTP policy support, which I talked to earlier, the multi-tenancy, again, talked about that earlier. You can also do some things with the credentials from AKO talking to the controller now. You can reference them in the secrets. We brought some controls around FQDN usage. And then a big piece of the release, and I'll talk a bit more detail in this in just a second, was our Gateway API support as well. And then from an AMKO perspective, we brought in multi-tenancy, and we've also brought in a bit more health checking as well. So data plane health checking, and now we can also leverage control plane health checking within a AMKO environment. So talked a lot about Gateway API, and I just want us to sort of reiterate exactly what Gateway API does and what the use case it is that it's solving for. If you are familiar with Kubernetes and you're familiar with Ingress, Ingress is a layer 7 traffic routing inside a Kubernetes cluster. It's been around some time, but one of the problems with it is it's quite limited. It's a API, and really all you can do with it is you can do a host or payoff-based routing. You can expose a listener, and you can do some sort of TLS decryption with it as well. But if you need to do anything else, and of course with Kubernetes environments today, we do want to do those things, you usually have to extend Ingress, and how you extend it can vary depending on which implementation you're using. Avi, for example, uses custom resource definitions. Nginx might use annotations. I think HAProxy use annotations. But the messaging is to extend Ingress, which is what we need to do to handle our modern application routing. We need to use these extensions. And now one of the problems with these extensions is that each, as we say, each Ingress implementation, they're different. And so what happens if I want to import my ingresses from the public cloud to on-premise or something like that? Normally I have to rewrite my ingress definition, rewrite my CRD, rewrite my annotation. So Gateway API has come around and said, no, we don't want to do that anymore. The Kubernetes community as a whole come together and said, okay, this is going to be the new spec for traffic into my Kubernetes cluster. And so you can see sort of the difference between the blue and the purple here is all of the things I can do natively in Ingress and all the things I can do natively with Gateway API. And you can see that there's a whole lot more things I can do natively with Gateway API. So now I don't have to extend my Ingress. Additionally, there are also a lot of other benefits from a RBAC perspective. Gateway API is broken up into sort of 3 different objects. I have a gateway class, a gateway, and a route type. And this enables me to provide RBAC around those different types. So now a developer can't control the traffic totally controlled the listener for the entire cluster. Now perhaps my platform team can provide the listener, and then my developer can just attach to that gateway. So fundamentally, a much more secure way of handling Kubernetes load balancing from a layer 7 through layer 4 perspective, and a much more extensible way to configure that. And as I say, this is, expect to see this a lot more if you're working within Kubernetes environments over the next sort of year to 18 months, as, various different vendors start deprecating Ingress and moving towards Gateway API. Where, from an Avi perspective, where have we been? So we introduced support for it in 1.11. We brought, as tech preview, we GA'd it in 1.12. With 1.13, we're bringing in support for sort of NSX Cloud Connector, bringing in our support for the no-port local, which is sort of our integration with Antrea. We've provided a lot of core conformance testing, so we're pretty much conformant with upstream Kubernetes from a Gateway API perspective. We can have wildcard listeners on the gateway. We can support multiple listeners, and then we can also have wildcard prefix subdomain support on a HTTP route. So again, it's just adding to that extensibility and flexibility of Kubernetes load balancing as a whole. Any questions in there? Well, just before I move over to, yes, Leslie. Yes, we will support TCP route. As far as I'm aware, and TCP route and UDP route are currently still in an experimental phase from an upstream Kubernetes perspective. When those go to, when they graduate out of experimental, we will support them then, if that makes sense. Are you looking to use, well, I guess you can answer in the chat. I don't think you can talk, but if you're looking to use them, if you wouldn't mind outlining your use case, etc., we're very happy to look into that as well. So yeah, talked about sort of AMKO and upstream Kubernetes. I do want to quickly talk about Cloud Foundry. PCF, Pivotal Cloud Foundry, has been named TAS before. Currently, it's called Tanzu Platform for Cloud Foundry. We've introduced, can't skip over to my slide. We've introduced some pretty nice integrations with Cloud Foundry as well, sort of over the last couple of months. It's a little bit outside of the usual release cadence, but seeing as we wanted to discuss it here as well. Fundamentally, what we can do is we can load balance the Go routers. So the Go routers are, the load balancer, the layer 7 load balancer that operates within the sort of foundation within the Cloud Foundry. And you need to load balance these Go routers. So usually a load balancer sits in front of them. We've now provided an integration with the Tanzu platform for Cloud Foundry, where that load balancer sat in front of your Go routers is sort of automatically provisioned, and it also, adds, when you scale up and down your Go routers, you'll be able to, it gets automatically added. So it gives you a bit of elasticity on the front and back end. One of the advantages we also bring to the TAS world, the Cloud Foundry world, is our analytics and logging. Abhinav, showed kind of the power of the Avi analytics, and bringing that into Cloud Foundry environments is quite a win. So you can, there's a little bit of a manual setup at the moment, but as we move into the future, look for more and more integrations here as well. Yeah, so do you want me to cover this last one, Abhinav, or do you want to do this one?
Yeah, there were a bunch of questions. I'll just answer one of them. One was around licensing. The question was, what are the licensing options? So Avi is licensed based on service units, which is the data plane vCPU capacity. So the service engines, the number of virtual CPUs it takes is what we charge with, and it is a 1 year plus license. So it could be a year or more of a license. All features, including GSLB and WAF, are part of the same license, so no additional SKUs. You just have to size for the use case. And yeah, it's only subscription, not perpetual. One more question, Chris, was whether the VKS uses Avi as of now. What's the message?
Yes. What is the specific question there? Yeah. So yes, absolutely it does. So post vCenter 8U2, there is a Avi integration with VKS. So with Supervisor, so the new name for it used to be called vSphere Tanzu, you might have heard of TKGS, now it's called vSphere Supervisor. vSphere Supervisor deploys VKS clusters. So AKO as a whole will exist within the cluster, within the supervisor. And for layer 4, it's automatically layer 4 is taken care of. And then for layer 7, you kind of install AKO over the top. But yes, fully supported in both VDS and NSXT environments. And if you do use this within VKS and supervisor, you will not use NSX load balancer at all.
Yeah, so there were a couple of other questions as well. So if you want, we'll just I've put my email address on the Q&A panel. You can just add it to the chat window as well. Feel free to reach out to me or to Chris, and we can answer any questions or get you connected for a demo or discussion on Teams.
Perfect.
To wrap it up, these are some additional resources which some of you were asking for. If you want to look at, the overall solution, download data sheets or feature guides, you can go to the first link, which is, the landing page for Avi. The second link is for a trial, so you could request for a trial license or, even have a hands-on lab available on the second link. And then if you want to go through a workshop, we have a 90-minute as well as a more extensive 4-hour workshop available for multiple geos. So we keep rotating between the US, Europe, as well as Asia Pacific time zones. So please go to the third link and you can register for one. That's all we had. Any other last questions? Cool. So this is the second in the set of 4 webinars on Avi. Do keep a watch out for the the next one in this series, which will be announced shortly. And hope this was useful. The recordings will be available, for registered attendees. You should be able to get it on your email in a couple of days. Thanks a lot. Have a good day or a good evening.
Thank you. Bye-bye.